Hey guys, Adam here with Old Santee Canal Park's education team. I know you're probably stuck inside and you want to get outside and learn something. So I'm bringing you a program today all about what's under your feet. So all you need to do is go into your own backyard and I'm going to tell you about stuff that you can find right under your feet. So first off, we've got to figure out what exists under our feet. So I drew a little diagram, bear with me. It's not the greatest diagram, but it's great for teaching. So what exists under our feet? So at the very bottom, of course, is bedrock. Bedrock is made of rocks. Rocks are minerals that exist all throughout the Earth's surface. They can come in three different types. They can come in igneous, they can come in sedimentary, and they can come by metamorphic. So igneous is made by fire, just like it sounds, igneous fire. So it's made by volcanoes and magma. And as the magma cools down, rocks form. So all rocks are minerals and they form by igneous rock by cooling down. Now sedimentary rock is formed by compression, usually involves water. So an example of a sedimentary rock is our limestone we have here at the park. Example of an igneous rock would be a piece of marble. Like our state rock, our state mineral is actually a blue marble. And I'll show you that here in a second. And then you have metamorphic, which is a combination. It could be a igneous rock, it could be a sedimentary rock, or it could be previously a metamorphic rock that changes due to pressure and temperature. So all that happens in this bedrock stage. After the bedrock, what happens is the bedrock gets broken down through erosion, through freeze-thaw cycle, and becomes eventually the parent material, which is a bunch of boulders. As those boulders break down, again through erosion, freeze-thaw, they'll become subsoil. Now, what we have for subsoil around here is marine clay, because all of this used to be covered by ocean at one period of time. So we have lots and lots of clay. Then after that, you have the zone of leaching, which is usually some kind of sand, which allows water to move back and forth. Then on top of that is topsoil. Topsoil is probably the most important for life because that's what helps support life is topsoil. And that's what everything uses to exist and get nutrients and water out. And then we have the surface litter. So that's the leaf layer you see in a forest. You can see it all behind me, all around me. So what we're gonna do right now, what I want you to do, you're gonna make your own layers of soil. And that's pretty easy. What I want you to do, I want you to find like an old soda bottle maybe, or maybe some container, a pickle jar maybe. And what I want you to do is we're gonna make our own soil layer just like this with your pickle jar or your soda bottle. And what I have is a beaker. So what I have set up here, okay, stay with me, I'm gonna move around, is some bins. So we have topsoil in this bin. We have a zone of leaching right here, some sand. We have clay in this bin. And then we have, stay with me. So we have some rocks in this bin. That's our parent material. So I'm gonna set you down right here so you can see what I'm doing. Okay. So what I'm gonna do now, I'm gonna take my beaker and I'm gonna start with the parent material. So just find some rocks. You could use fish tank rocks like I'm using here. It could be rocks out of your own yard. It could be pretty much anything you want it to be. So, but just find some rocks, put it in the bottom. It doesn't have to be full, just enough. And then I'm gonna use clay. You can use Play-Doh, for example. That's a great clay. So I'm gonna add some clay to this. So there's my clay layer. Then I'm gonna add my zone of leaching. So I'm gonna add my sand. All right, there's my sand. Okay, it kind of fills in the cracks, but if it was true clay, it'd be packed really tightly so that sand wouldn't go through it. Then we have our topsoil here. So I'm gonna add my topsoil. All right, there you go. And then I'm gonna add some leaf litter. So there's your zone, your different zones, your different horizons, they're called. And that's an example of what is underneath your feet. Now, a lot of people say that soil is not living, is dead. And we as scientists, we want to prove whether soil is living or not. So we have to do an experiment. So next thing I want you to do, I want you to grab a cup, just a Dixie cup, maybe a plastic cup, could be any kind of cup that you don't mind getting dirt in. And then I want you to get some hydrogen peroxide. So hold on one second. All right, so I found my cup. This is just regular old plastic cup. What I want you to do is I want you to go and find and fill this cup half full of dirt, okay? Make sure there's no leaves or no bugs in it, just dirt. So I'm gonna fill my cup up half full of dirt. So I've got it half full, a little more than half full. I'm gonna dump a little out, okay? So there's half full, all right? It's not exact. So what we're going to do with this experiment is all experiments are done to answer questions. So the question that we have to answer is soil living or non-living? So you have to come up with a hypothesis now. There's a process called the scientific process you have to do with every experiment. So the process that we have to go through is first we have to come up with a hypothesis. Hypothesis is what you think is going to happen. So do you think soil is living or non-living? I think soil is living. So now we have to find a way to test our hypothesis. We're going to test our hypothesis with this CVS brand hydrogen peroxide. So just any old hydrogen peroxide will work. So what you're going to do is you're going to pour a little bit of this into your cup and you have to observe what happens. So what I want you to do right now, I want you to smell the dirt. I want you to listen to the dirt, see if it speaks to you, okay? I want you to stick your fingers in the dirt, see what the temperature's like, how wet it is, okay? How cold, all right? So its consistency, just feel it. And then I want you to look at it. I do not want you to eat the dirt. Don't eat any dirt, okay? So no tasting. We're gonna use our other 4 senses besides taste, okay? So now that you've done that, you know what it looks like, you know what it smells like, you know what it sounds like, you know what it feels like, you're going to add the hydrogen peroxide. So you don't need a lot, just a little bit will do, okay? Just a little bit will do. And then I want you to watch and see what happens. Okay, all right, just watch, see what happens. I'm gonna add a little bit more, okay? I want you to take note to see if there's any bubbles or any sizzling, okay? I want you to listen. All right, I want you to look at it. I want you to stick your fingers in it, okay? Stick your fingers in it. I know it's messy, but dirt doesn't hurt, okay? Just stick your fingers in it, feel it. All right, look at it. Then I want you to make your observations. What are your observations? So my observations, all right, is that it's bubbling, okay? I can hear it popping and sizzling, all right? I actually felt a temperature difference. It actually got warmer for me. So I don't know if you noticed that as well. It also got wet, and I smelled it, still smells like dirt, okay? So that's not really a result. It is a result, but it's not really anything. It tells us nothing. So with our results, right? We heard it sizzling and popping. We saw bubbles, okay? So we felt a temperature change, which means there's a reaction that occurred. So all of this points me to draw a conclusion from our results. So conclusion is soil is alive. It's very much alive because it supports all this beautiful trees and plants that rely on it. So the next time you walk outside and think dirt is just dirt, think again. There's a lot that adds up to being dirt. So please check back with us on every Wednesday and see what other programs that we have to offer. Thanks for joining me, and look forward to seeing y'all next time.